In this lesson, we'll look at the difference between descriptive statistics and inferential statistics. The statistics that most of the statistics we've done so far, especially those things in Chapter 1 and 2, like creating graphical displays showing the distribution of data or summarizing a data set with a mean or a standard deviation, something of that sort, those are, in general, descriptive statistics. Inferential statistics is the process of using some data that we have, and we might summarize it like we would in descriptive statistics, but we gather the data from a small group and use what we find in the data to infer things about a larger group of individuals. So that's kind of it in a nutshell, but let's go back and look at each one a little bit better. When we're looking at descriptive statistics, the name it basically says it all. Descriptive statistics are used to describe data. And we do this again by using various graphical summaries or summarizing with measures of center, spread, things like that. Now when we go to inferential statistics, the key idea here is that we have a group that we want to know something about, and it's a large group. It's too large for us to gather data for the whole group. So that large group is called a population. So we want to know something. Whoops. We want to know about a large group called the population. Let's try a change of pencils here. About a large group called the population. We do this by gathering data from a smaller subset out of that group. A subset meaning just some of the people, some of the individuals, may not be people, but some of the individuals in the population. We grab some of them and we try to do it in a random way so that we're looking at all variety of individuals that might be in the population. So we gather data from a subset of the population called a sample. And we look at that sample, and most commonly what we'll do is compute, say, a proportion or maybe a mean for the sample, and then what we do is extrapolate or just infer that mean or that proportion holds for the population as well. Of course, there's the possibility of error, and we'll get into that more later. Okay, but again, we gather data from a subset of the population called a sample. The sample has to be what we call randomly chosen from the population. And the process of randomly choosing those individuals is called sampling. And there's various ways of sampling, and we may or may not have time to discuss those. That is a complete science in itself. Now let's look at some specific examples of kinds of statistics and try to determine in each case whether or not we're talking about describing descriptive statistics or inferential statistics. Let me reiterate though, when we have descriptive statistics, they describe data for the entire group that we're interested in. And when we have inferential statistics, that's when we want to know something about a large group called the population, and we do it by sampling, by taking a few individuals out of the population and making some sort of measures for them. So as a first example, let's suppose that we have this situation where we're in a plywood factory and 1 out of every sheets of plywood is tested to see if the plywood is as strong as it's rated. So you can see here we want to know something about the plywood that we're producing in general, but we determine whether the plywood is strong enough by looking only at 1 out of every 100 sheets. So we're clearly sampling in this case. So that's an example of inferential statistics. For our next example, let's suppose that we look at all the currently enrolled students at OIT, and we create a bar graph showing the areas of study. We'll break it up into something large like engineering, health science, social science, or something like that. But if we create a bar graph showing the areas of study of all the currently enrolled students, then we're not sampling. We're looking at the entire group, and we're just summarizing their majors or areas of study. So that would be an example of descriptive statistics. For our next example, let's suppose that a professor looks at the students in a course they're teaching, and they determine an average course grade for the students in that course. Then again, the professor's looking at all the students in the course, and so this is there's no sampling being done, so this is once again descriptive. And for our last example, let's consider, suppose that maybe the folks from waste management are looking at recycling, and they study the recycling habits of 100 Klamath Falls households. They observe their recycling habits, and they do this in order to determine recycling capacity needed for the entire city. So in this case, they're looking at the entire city, but they're basing whatever they decide on these 100 households. So in that case, the 100 households is a sample. The population would be all the households and perhaps businesses as well in Klamath Falls. And so we're determining from a sample, so that's inferential statistics. So let's summarize again the difference between descriptive and inferential statistics. The main thing is that inferential statistics occurs when we have sampling. When we don't gather data for an entire population, but just from a sample out of that population. So we have sampling from a population. And descriptive statistics are when we describe a set of data using graphs or measures. So descriptive refers to an entire set of data, describing a data set. Now, there is a little overlap here because we can do descriptive statistics for our sample. We can describe the entire sample, but then if we actually go beyond the sample and deduce something about a larger population, then in that case it's inferential statistics.